Hello, everybody. What we're going to do is we're going to go over, well, that light's making a mess of things. We'll do it real quick like this. We're going to go over inductors in an AC circuit. I'll let it wash out. An inductor resists change in current of a circuit. An inductor, most basic inductors, is a coil wire. You'll see here it's represented this way as an inductor, as a fixed inductor, variable inductor, iron core inductor, and another way that a variable conductor can be shown on a schematic. An inductor, when we talk about inductor, it's represented by an L. When we start talking about the math formulas, an inductance is measured in henries. Eventually, you're going to get into impedance, and that's where inductive reactance will become important. Inductive reactance is represented by X sub L and is measured in ohms, like resistance. So they'll both be in series and in parallel circuits, and they can be in the combination. We're just going to talk about series and parallel right now. So to find total inductance in this series circuit, you're just going to add L1 and L2 together. Got to label that as L2, which I'll do right now. L1 and L2 together, and that'll give you your total. So the formula to find total inductance is L total equals L1 plus L2 plus L3 plus Ln. N represents the infinite. In a parallel, so this functions just like a resistive circuit. Parallel functions just like a resistive circuit. Also, you do, when you have L1 and L2, use the reciprocal formula where L total equals 1 over L1 plus L2. If there's more inductors in the parallel, that's L total equals 1 over L1 plus 1 over L2 plus 1 over L3 plus 1 over LD infinite. Now, if I'm looking to find my inductive reactance, and I have my inductance, this is the formula. 2 pi times the frequency times the inductance. Inductance is measured in henries. So frequency in the US, frequency is measured in hertz. In the US, frequency is 60 hertz. In most of Western Europe, it's 50 hertz. So it would be 6.28 times 60 times whatever the inductance is. In that case, it's 2. So it'll be 120 times 6.28. And I got to do it manually because I misplaced my, let's see, 6.28 times 120. So 753 ohms if we're using this. And if we're looking at to find, if we're given the inductive reactance in a series, you add them up to get your total. In a parallel, you set up the reciprocal formula again. And you find your total inductive reactance. Inductive reactance, like I said, are going to play later when we get into impedance, when we start doing resistive and inductive circuits, and when we start doing resistive, inductive, and capacitive circuits. But right now, this is the basics you need to know. I'm not going to work out a whole lot of problems. If you need that, I'm sure you can find them in any textbook you have or any workbook that goes along with a text like this. But this is just the basics. And that'll do this. Everybody have a good one.